This first video, I'm gonna go through some basic concepts about stars in general so we can get a good understanding. So we start by asking this question of what are stars? How do we define stars? Well, a star can be defined as a self-gravitating celestial object in which there is, or there once was, in case of a dead star, sustained thermonuclear fusion of hydrogen in their core. So what does this all mean? Well, we can begin with the concept of fusion, right? So in the sun, hydrogen is fused into helium via nuclear fusion. So this process we call fusion combines hydrogen together to form helium, which is we can write it as 4H. They combine together. H here stands for hydrogen, and He plus energy. Right, this stands for helium. So the process of which we call fusion is when you combine hydrogens into helium. And this process emits energy as well. And this process only happens in the center of stars. Because in order for this to happen, there needs to be enough pressure to push all the protons together close enough to each other, so close so that the strong force comes into play. So what is the strong force? Well, strong force is the force that binds the proton and neutrons together. So if we have helium, which is just something like this, right? There's 2 proton, 2 neutrons, right? So what force binds them together? Well, it is what we call a strong force. And we know from Coulomb's law, which we learned in high school, that if we have a positively charged proton and another proton, they're both positively charged. So right here, there's going to be a repulsive force between them, because that's what the Coulomb's law tells us. So in this case, you need to bring the photon close enough together at which the strong force, which is the force that binds the neutrons and the protons, take over. But this requires energy, and the center of the star is perfect for that. And each time the hydrogen fuses into helium, their energy emitted. And what this energy is, this energy can be written as E equals to mc squared, right? The energy emitted is E, and then mass is how much mass was used in this process, and c is the speed of light. So I'm not going to get too deep into that, but that's basically what this is. So this reaction, what I have just wrote here, is kind of misleading, because it makes it seem like, okay, 4 protons and then they meet together and they just form helium. But in reality, the process at which this process is much more complicated than just four protons together and they just form a helium. It go through like a chain of chemical reaction, which I will discuss later, and this video will just be a brief introduction. So now we know what happens in the middle of the stars. Now we can ask the next question. Well, how are stars formed, right? Like, how did stars form? Well, imagine there are like molecular clouds in space, right? I'm getting a very bad drawing here. So imagine these are just clouds flowing in space. Well, we know force of gravity is that mass object has gravity, and they pull each other together, right? What happened is, throughout this process, there's going to be gravitational collapsing of these clouds. So there's going to be gravity. Okay, let's say I have a molecular cloud right here that's kind of small. Like the one that's here is kind of big. Like imagine our Earth and the Moon it kind of works like that. Like this bigger one with the big M is going to have more mass than our small m. So what's going to happen is that it's going to pull the small mass into the big mass, and now they just combine. Let me get some more pages here. So what happens here is that they will just combine to even bigger clouds that's composed of m plus m, right? It's the mass of the combination of these two. Then what's going to happen is that you can imagine, well, now we have a combination. Now this is going to even have a bigger gravitational force, because it just gained a mass from a small m, right? And then this is going to pull other molecular clouds in. So this is what we call the gravitational collapsing, right? Is They come together by gravity, and gravity pulls them together. And what's going to happen is that when gravity keeps pulling them, and we get more and more molecular clouds this way, there's going to be higher internal pressure, and the density is going to increase. And at some point, the pressure is enough for us to start a fusion, right? Because remember what we just talked about, like this process is bringing protons together, but where does that energy come from? Well, gravity, or you need an environment such as a center of a star where there's high enough pressure. So these molecular clouds combining other molecular clouds together create such a condition for this fusion to happen. So that's what happens here. And when fusion starts, right, it has an outward pressure caused by fusion at the center of the stars. Well, if that's the case, it would just expand indefinitely. But gravity comes into place too, right? Gravity pulls everything inward, while fusion exerts outward pressure. So when these forces reach an equilibrium, the star no longer expand, and it's at a thermal equilibrium, which is what our sun is look like. So what that's gonna look like? Okay, imagine this is the core, and then this is where all the fusion happens. So fusion happens like this right here. So what that's gonna do? That's gonna exert an outward pressure. That's gonna expand the entire molecular clouds, right? And then, well, if they just expand, can it expand indefinitely? Well, no, because there's also gravitational force that is pulling it inward. And at some point, the force that exerted by the core, by the fusion, is going to reach an equilibrium with the gravitational force. And it's going to form an outer layer where at this layer, the force is balanced between the force created by the fusion and the force of gravity, right? And that is just how our sun is going right now, right? Our sun no longer expands because it has already reached an equilibrium where the gravity at the edge is strong enough to hold it together, to not have it expand, but at the same time not pull it inward, because there's also pressure coming from the core, from fusion. So that's what's happening to our sun right now. It's at a equilibrium. And then eventually, at some point in the star's life, the star will run out of hydrogen to fuse, right? Because in this process, you just keep fusing hydrogen into helium. There's no more hydrogen being pulled into the equation, right? So it's like, imagine you have a car and you have fuel. If you just keep burning the fuel, you're gonna run out of fuel eventually. So what happens when a star run out of fuel, or we have no hydrogen to spare here for fusion? Well, the outward pressure will reduce, right? Because remember, this force from the inside to the outside, like this outward pressure is funded by the fusion. And if there's no hydrogen to fuse, then gravity will win, and then it will pull the star inward even more. So what this is going to do is that this is going to cause the core to contract, right? Because the gravity is the same, but the pressure is not there from hydrogen anymore, because hydrogen has just ran out. So it's just going to pull the entire thing inward. So it will become something like this, where the gravitational just push it even more further down, while the core, and then what this is going to do to the core is that the core is actually going to contract. So it's going to keep getting more dense. So the particle keep getting closer and closer to each other. Then the result of that is that the kinetic energy is higher, and the temperature of the core becomes hotter. Now we have a even hotter and higher pressure environment. Then what's going to happen is that our helium is going to start to fuse, just like hydrogen once did. They will fuse into carbon. So that equation goes something like 3He. Then this is going to fuse into carbon plus energy, right? Exactly the same process as before, where hydrogen fuses into helium. So the whole process can be summarized as we have hydrogen, they're fusing into helium actively, and then eventually you run out of fuel, you run out of hydrogen fuse. So that's going to result in a less outward pressure, which is going to cause the gravity to push it inward, and then push the core even more closer to each other, then contracting the core. And that is going to create even a hotter and even higher pressurized environment where helium can even be fused into carbon. So that's how it works. Now, since the core have contracted, the outer layer are now further from the core than before. So that is going to do is that there's less gravity and the outer layer is gonna expand, right? So that's what's gonna happen to our star one day too, our sun, right? One day it's gonna run out of hydrogen to fuse, and the core is gonna contract, and the outer layer is gonna expand. It might eventually even swallow our Earth, but we wouldn't be alive to at that point to see that happen, right? Because that's gonna be in like what, like 5 billion years old. None of us here would be alive. Sad to say that, but that's the truth. So, and then what happened is that this fusion, it just keeps cycling and keep producing even more elements. So the final outcome of a star is based solely on its initial mass. So its initial mass will determine if it becomes either a white dwarf, so I'm gonna write that down, or a neutron star, and a black hole. So exactly which the outcome. So these are the three possible outcomes of a star when it dies. And what the sole factor that determines which category it falls in is its initial mass. And in really massive stars, these nuclear fusion will happen and they will produce even heavier elements like carbon, oxygen, silicon, all the way up to iron. And this process is called the nuclear synthesis. Because at the start of the universe, when the Big Bang happened, there were only hydrogen, helium, and some amount of lithium. So stars are like the universe production factories, right? They generate hydrogen. They generate oxygen. They generate carbon, and silicon, and all these elements. So amazing and profound implication of what I just said is that it means all the oxygen that you're breathing in right now, or all the carbons you're made of, they once were inside of a center of a star. So I think that is kind of like philosophical in a sense, like fascinating how what made of us, what we breathe in, they're all once in a very dense environment in the center of a star. And at the end stage of a star, it will go boom, which is a supernova. The supernova will spread all these elements it has produced into the outer space, and then maybe slowly in millions of years, these elements that was like spread out by the supernova will bind themselves again together by gravity, and it goes back to the original cycle with the molecular clouds again. They form together a star. So basically a star will go. So at the end, the star would die. There's gonna be a supernova. It's gonna spread all the elements that it has produced in the fusion, and then maybe after millions of years, even longer, that these gas clouds come together again to form another star. So it's really like a star dies and then the star forms. So cycles begins like that. And that is all I have to say for this 1.1 session. And in the next section, I'm gonna go in detail about a lot of this, right? Because we only went very briefly through what has happened. Like I didn't really explain the chemical process that we have here, like what exactly does it mean and stuff. But we're gonna go into that later on. So this is gonna be the first lecture.